Let's go into the layman explanation on the connection of a solar inverter system. Let's talk about in a scenario whereby you're having a new installation to be done on site. Let's start with the basic installation. Let's say a 1 kVA solar inverter system, and oftentimes you're given certain components like you have our inverter, you have our charge controller, you have our voltage protector, the breaker box, the changeover, and certain other accessories. Okay, coming. Have them here. Okay, I'm coming. Okay, let's take the inverter here. All right. Okay. Then the battery over there. So oftentimes, the basic thing, like I highlighted in the other class, talking about the component of solar inverter system. So let's say we have our battery. We are going for a 1 kV installation, 1 kV, 1 kVA, yeah, 1 kVA. All right. And we're giving a single battery. It's a 1 kV 12 volts. Most of times, the 12 volt system. We have our battery. The batteries has terminal. They have the positive and the negative. You understand? So the battery have the terminal, the positive and negative. You actually see it from. It's most times labeled. Other times they use red to indicate the positive and the black to indicate the negative terminal. All right, let's say the battery is 12 volts, a 12 volt battery, 220 AH. All right, first thing is checking our inverter. This a 1 kVA inverter system. You check your parameter oftentimes. Here we have 1 kVA system, 1050 volts. Okay, so what you do is connecting your inverter. Let's see, we have our inverter. Draw the 1 kVA inverter. 1 kVA inverter. It's a 12 volts. All right. So the inverter as well, we have the positive and the negative. They say the positive terminal and they have the negative. So other things that we have on the inverter, we have the output. Let's say this is the output. And just using an indicator, we have the live, the neutral, and oftentimes we have the ground. You see a symbol, something like this. So let's say common neutral inverter. Let's say you now have the neutral again, then we have the live. So let's say this ends. This is the output side. Let's say the output. Let's say this is the input side. Input. So when we talk about the input, we're talking about the charging, whether from the grid or from the gen. When we talk about the output, we're talking about the supply to the house, to the appliances you want to use in power. All right. Okay. All right. Let's proceed. Then we have the controller, the charge controller. This is a PWM model. So the controller has the battery side. As you can see, we have three terminals. We have the panel side, understand, and the DC load. Now let's say our controller. Okay, this is the DC load side. DC load is something like a bulb and turn on. Then you see the panel, the battery side where they have the BAT. You have the positive and the negative. Then you have the PV. That's the solar panel. You have the positive and negative. Please, most times always check the labeling. They will write the name. It could actually be battery or PV. They may place it other way, but just check. It may not just be according to the diagram above. All right. The first stage is to connect. Uh, this is quite important. When connecting your controller and the panel. All right, let me draw the panel. Let's say we are giving two pieces of 220-watt panels. We have 220-watt solar panels. We have the positive the positive, then negative, the positive, then the negative. In one of our classes, we've talked about the series and paralleling, which I will not be doing that today. But let me just put it in summary. What we are doing is we are paralleling these panels. We're going to be paralleling the panels. We're going to be paralleling the panels. Okay, this is our negative, and this is here is our positive. And positive, positive. All right. Now, the first thing to do is you connect your positive of this, then to the battery. You add the positive to this, then the positive to this. Most of these controllers are designed to work in um, different voltages. As you can see here, we have this controller 30 amps, which can work with 30, 12 volt and 24 volt system. So once you connect the battery positive and negative to the controller comes up and it is programmed to work with 12 volts. Now after that, connect your uh, battery. We have our positive of the battery. Don't mind, this is a jumper sign. Okay, so it goes to this, goes to the positive. Then connect the negative as well to the negative. At this point in time, the inverter can actually work on its own without any source of charging, whether from the panels or NEPA, as far as there's energy on the battery, new battery system. Okay, so once that is done, um, the solar panel can come in. Solar panel, we have the negative, by then we have the positive entering the terminal. So at this point in the day, the solar panels will be charging the battery, and whenever grid in the night, energy stored, or whether in the day or night, energy stored on the battery could actually be used to drive our loads. The inverter will convert the DC form of energy on the battery to AC to power our appliances. So this is the AC output of the inverter, the output, the live and neutral output. So the input, if you want to charge, is you have the live and neutral input. Now, one other areas in this is the distribution board. The distribution board in the house. The distribution board in the house. We talk about the changeover system. We have the breakers. And we have the voltage protector. So we have uh, breakers, monitoring device around this just to complement the system and make it better and function properly. You understand? All right. I think that's that in brief. To recap what I just said, we have the battery, the panel, the charge controller, the inverter. We have the cable. Don't forget, I didn't mention that. We have the DC cable, the AC cable for the output and the input, the DC cable for the connection of the inverter to the battery, the connection of the panel to the controller. So the first stage is connecting your battery to the controller and the battery to the inverter. So this next stage is connecting the panel, which is placed where the how do I put it, sun radiant energy will fall upon it. Yeah, the most. So the energy, this here form of energy will come here, and the solar charge controller, the charge controller will serve as an intermediary between the batteries and the panels. So to prevent overcharging and automatic discharge. So why this inverter does the work of converting the DC stored energy to AC, which powers our appliances, the TV, the bulb, the fan, the AC, and other gadgets. Thank you for joining this section. It's Meened Global Vocational Institute.